In this question, we're looking at finding the surface area of a rectangular pyramid. So this is the information that we're given. The base of the pyramid has dimensions 4 meters by 6 meters, and the pyramid itself is 8 meters tall. So I'm doing this example, I'm going to do a few extra steps to try and help you understand what's happening. And then if you're doing a question on a quiz or something, you don't have to have a net, you don't have to have a diagram, but I do believe that it helps. So with a rectangular base pyramid, we have two pairs of triangles. So we have to solve for them separately. The number that I need, I do know what the dimensions of the base is in this pyramid, so I can label that now. So it was a 4 by 6. So if I look at my diagram, which is slightly exaggerated, so we'll do 4 meters by 6 meters. In order to calculate the area of the blue triangles, I need the height of that triangle. When it switches over to the three-dimensional object, that height of that triangle is actually a slanted distance that goes from the center point of this side up to its apex. So this red line on our net is actually this red line on the object. So in order to calculate that, we know that the height of it is 8, and we're looking for this slanted dotted line. So we're actually going to create an imaginary triangle that goes from the center of the base out to that midpoint on that side and all the way up to the apex, and that's a right angle triangle. And we're going to use Pythagorean theorem to find that slanted height. So here's one of the tricky parts of this question, is trying to figure out what the dimensions of that imaginary triangle that we just made are. One of the lengths, the only length that we need to find to complete our Pythagorean theorem, is going to be this length right here. So how wide is it from here to here? If we look at drawing a line from the whole distance, if I go from here all the way across, then I know that that is 6 meters. So I'm actually just doing half of that. So I know that this bottom leg of my triangle is going to be 3 meters. A squared plus b squared equals c squared, or whatever variables you want to use. And I know that this side is going to be 3, and the other side that I know is 8, and we're solving for the hypotenuse. So it's going to end up being 3 squared plus 8 squared, which is going to give me my slant height squared. 3 squared is 9, 8 squared is 64. I'm looking to find my slant height squared. When I add these together, I get 73, and my final step to solve for the longest side is to square root both sides of this, so I get c all by itself. So I've already put that into a calculator, and I get that the square root of 73 is this big long number here. Now, if I'm looking for accuracy, I know that my answer, it said that it wanted to the nearest square meter. So I'm going to keep about 4 decimal places here. If you wanted to leave it as the square root of 73, you could, and complete that and use that the whole way through. But I'm just going to use this decimal number up here. So my slant height for that blue triangle is going to be 8.5440 approximately. And I'm going to just take that now and put it in here, 8.5440, and I'm going to use that to just go ahead and solve for the area of this blue triangle. So this triangle here, and this is another place that we have to be careful, this base is 4. I know that we were using this distance here to calculate the bottom, but we're not using this green triangle anymore. We've already got the information out of it that we need, so we're back over here. What is this face here that goes up this side of our pyramid? What is that area of that face. So we need to use the 4 and our newfound height. So the area of a triangle is half of the base times the height, and we know that our base is 4 from our picture, and our height is this new slant height that we found. And when you put that into your calculator, you're going to get 17.088, 17 and 88 thousandths. So that 17 and 88 thousandths is the area of one of those blue triangles. I'm now going to move on and try and calculate the height of the red triangle. If I go over to my model, that line there, which will make it a different color, let's make it purple. That line there coincides with the slant height of the front face of our pyramid. So we're going to go from the halfway point up to here. So that distance there is the exact same as this distance, the height of this triangle here. Or this one, whichever one you want to use. So we're once again making an imaginary triangle on the inside of our object. And my picture is going to be slightly off, but that's okay. If you can imagine that this is the halfway point on this edge. So what are our dimensions of this imaginary yellow triangle? Well, our height is 8, and this bottom distance here. So that bottom distance is going across the base in this direction. And if we look over here, we know that that's 4, so then this part here has to be 2. So once again, we have to be careful when we're finding that one. So we're going to start by using Pythagorean theorem. We have a 2 and an 8. So we're finding slant height of the other triangle. So we have a squared plus b squared equals c squared. We had a 2 for our smaller leg, and we had the 8, which is the height. And we're looking for c squared. 2 squared is 4, 8 squared is 64. So we're looking for the square root of 64, and that's going to be our slant height of the other side, the other triangle. So that's already completed. Down here, no, wrong one. So the square root of 68 is that long number. Once again, I'm going to keep about 4 decimal places, so I know that 8 and 2, 4, 6, 2 is equal to our slant height on that other triangle. And if I find the area, so I can use that 8.2462. So that's what this distance is here, 8.2462. That's a 4. And that's what we expected. We knew it had to be a little bit less than the height of this triangle on the side. That triangle has to go further to get to the apex because of its placement on the pyramid. So we're going to do 1/2 of the base times the height, and this time our triangle has a base of 6 and a height of our new slant height. So we will do 1/2 of the base times the height for our triangle. Our base is, I'm going to go back and check again, our base is 6. And our height is the 8.2462 number. And when I calculate that out, 6 times that, divide by 2, you get 24.7386 square meters. If you're using sketches, you could go up and you can put that in there to show your area, and that's in meters squared. Finally, the only shape left that we have to get the area of is the base, which should be the easiest one. So it has dimensions 4 by 6, so the area of the base is going to be equal to the length times the width, and we have it as 6 times 4, so our area is 24 meters squared for our base. So I have it over here as this is one of the triangles, that's the other triangle, and I have my base, and then finally I'm going to find the total surface area. So I'm going to have all 5 shapes included. So I'm going to write one long statement. So the total surface area is going to be 2 of the blue triangles, which were 17.088 square meters, plus we had 2 of the red triangles, which were 24.7386 square meters, plus we have our area of our base, which was just 24. And you can see where these numbers come from on our question. If you're doing this question on a quiz, I would probably be underlining these because these are some of your big checkpoints along the way. Those are going to get you points. You have a final statement that's going to put them all together. You put that in your calculator, and you get a total of 107. So the surface area 107.6532 square meters. Question asked it to the nearest square meter, so we round it. That's a 6, it's over halfway, so our surface area is approximately equal to 108 meters squared. And this is what our final answer is. If you're on a quiz, you're going to want to write a statement if it's a word problem.